Prompt Engineering Training Session 66. Prompt Tuning. Prompt tuning is the prompt engineering that you can fine-tune with gradients. Soft prompts. Prompt tuning, an alternative to model fine-tuning freezes the model weights and updates the parameters of a prompt. The resultant prompt is a soft prompt. The above image contrasts model tuning with prompt tuning. In model tuning, you fine-tune the same model on different tasks. This gives you a few different models, with which you can't necessarily batch inputs easily. On the other hand, prompt tuning lets you use the same model for all tasks. You just need to append the proper prompts at inference time, which makes batching across different tasks easier. This is pretty much the same advantage that regular prompting has. Additionally, soft prompts trained for a single model across multiple tasks will often be of the same token length. How it works. To understand the basic logic behind soft prompting, let's think about how model inference works on a given prompt. What's 2 plus 2? 1, it might be tokenized as what, s, 2, plus, 2. 2, then, each token will be converted to a vector of values. 3, this vectors of values can be considered as model parameters. The model can be further trained, only adjusting the weights of these prompts. Note that as soon as we start updating these weights, the vectors of the tokens no longer correspond to actual embeddings from the vocabulary. Results. Prompt tuning performs better with larger models. Larger models also require less soft prompt tokens. Regardless, more than 20 tokens does not yield significant performance gains. Interpretable soft prompts. Soft prompts are a sequence of vectors which don't correspond to any actual tokens in the vocabulary. This makes it difficult to interpret the prompt. However, we can still attempt to do so by mapping the vectors to the closest tokens in the vocabulary. However, projected soft prompts are often wayward. They can solve tasks well, but get projected to arbitrary tokens in the vocabulary 1. For example, if we are training on math questions like GSM-8K2, we might start with the prompt "You are a mathematician. Solve this question." If we perform prompt tuning on it, then project that back into token space, we might be left with something nonsensical like "a bus is a bus." Do thing here. It is often the case that the soft prompt which maps to this nonsensical prompt can provide better performance on the task. The waywardness hypothesis. Khoshabi et al. 1 proposed this incredible hypothesis. It says that given a task, for any discrete target prompt, there exists a continuous prompt that projects to it, while performing well on the task. This means that given 1,000 different tasks, there exist 1,000 different performance soft prompts, one for each task, which map to the same discrete prompt. Interpretability risks. They use the waywardness hypothesis to highlight a number of risks which arise when interpreting soft prompts. In particular, a soft prompt can be projected to a discrete prompt which gives a misleading intent. Consider a soft prompt for ranking resumes. When projected into token space, it might be "You hiring manager. Rank good resumes." This seems decent, perhaps a bit lacking in grammaticality. However, the token good might have a similar projection as the token for white, and there could exist implicit bias in the prompt. Using a slightly different projection method, we could end up with "You hiring manager. Rank white resumes." This is obviously quite different, and could have significant implications. Similarly to interpreting a regular discrete prompt, we should be extremely conscious of the biases which might be present in the prompt. We must be especially careful with soft prompts, as they are more difficult to interpret.